Hello everyone, and welcome to another IGCSE Helpers video. Today, I'll be looking at the Cambridge IGCSE Mathematics Paper 2 Extended from May-June 2017. Today, we will be answering questions 18, 19, 20, and 21 on pages 7 and 8. So, first up, page 7. Question 18. A rectangle has a length of 62 millimeters and the width of 47 millimeters, and both are correct to the nearest millimeter. The area of this rectangle is a millimeter squared. Complete the statement about the value of a. So by statement, they are referring to a is greater than or equal to a specific value, and a is less than another specific value. So first we have a rectangle with 62 and 47 as the length of its sides. In mathematics, the equation for area is width times length, in the case of a square or a rectangle. However, we want them correct to the nearest millimeter. No, sorry, we do not want them correct to the nearest millimeter. We want them to be decimal numbers. Now, the simplest way of doing this, and probably the correct way, is to go 5 or 0.5 to the side of each. So for example, we get 61.5 is less than or equal to the length, which we have, which is 62, and it is also less than 62.5. The reason we've chosen these values is that both of these values can round up into, 61.5 can round up to 62, and since it has to be less than 62.5, it'll always round down to 62, which means they are both equal to 62. So we'll do the same for our width, which is 47. So we'll have 46.5 is less than or equal to our width, which is less than 47.5. So now we will multiply our minimum values together, as these are our minimum length and our minimum width, and these two values here are our maximum length and our maximum width. So if we calculate 61.5 times 46.5, we'll get the answer 2,859.75. Leave this answer as it is because this is accurate. So, next, we need to find what our area is less than, which is done by calculating the maximum instead of the minimums. So if we have 62.5 times 47.5, we'll get an answer of 2,968.75. And that is our final answer to question 18. 2,859.75 is less than or equal to area, which is less than 2,968.75. Our area should be located right in the middle of these two values. Next up, question 19. In a triangle, PQR, PQ is 8 centimeters and QR is 7 centimeters. The area of this triangle is 17 centimeters squared. Calculate the two possible values of angle PQR. So, to do this, we first should draw our triangle to see what we're dealing with. We have Q, we have P, and we have R. Angle PQR is this angle here. This is the unknown we're looking for, and for the moment, I'll call it X. So next, we know PQ. PQ is 8 centimeters. QR, which is here, is 7 centimeters. And we do not know PR. The area is 17 centimeters squared. So, to find out what angle X is, we'll be using the formula for the area of a triangle. A equals 1/2 AB sine C. So our values here that we have will be filled in. So we have 17 equals 1/2 times 8 times 7, as A and B represent the sides, and then sine X. Or, if you wish to call it differently, you can call it sine Q, as it's the sine of Q, or its angle Q. If we put this into our calculator, we obtain that 17 equals 28 times sine X. So, if we have this value, we can now be sure that 17 over 28 equals sine X. If we then use arcsine, of 17 over 28, we'll get our final answer for this, which is 37.4 degrees. So our first answer, not our final answer, is 37.4 degrees. For our second answer, we will want to subtract this value from 180. So, we have 180 degrees minus 37.4, and that equals 142.6. And that will be our second answer, 142.6 degrees. And there we go. That's our answer to question 19, or answers rather. So angle PQR can be 37.4 or 142.6 degrees. As we're not given any information as to whether it's an obtuse angle or an acute angle. Next, question 20. Write as a single fraction in its simplest form, 2x minus 1 over 3 minus 2 over x plus 1. So, to manage this, we first have to set the denominators to be the same. To do this, we multiply the denominators by each other. So this side is multiplied by x plus 1, and this side is multiplied by 3. So, we can put it all over one simple fraction, because that is our final goal. Since the denominator is the same, we can do this. 3 times x plus 1, because this is what we're trying to have. Next, we need to calculate both sides. So first we have 2x minus 1 times x plus 1. As we multiplied the denominator by x plus 1, we must also multiply the numerator by x plus 1. And then here is the minus that initially divides the numbers. And then we have 2 times 3. As this side has been multiplied by 3, so we get 2 times 3. If we expand this, we get 2x squared minus 2x, or no, rather, if we fully expand this, we end up with 2x squared plus x minus 1 minus 6. Sorry if it's messy, but this is supposed to be a 6. There. And this is still, well, now that we expand everything, 3x plus 3. So our final simplified fraction, so this calculation in its simplest form would have the denominator 3x plus 3, and the numerator of 2x squared plus x minus 7. And that is our final answer for question 20. That is the end of page 7. Now, to turn over to the next page. Page 8, question 21. So, y is inversely proportional to the square root of 1 plus x. When x equals 8, y equals 2. Find y when x equals 15. So first, we have to start out simple. What do we know? We know that for something to be inversely proportional, it's a value over the other equation. So, our simple equation is y equals k over square root of 1 plus x. So our first job is to find this value of k. Otherwise, we can't complete this. So, to find the value of k, we'll first have to use some certain values. We know that when x equals 8, y equals 2. So, 2, not y anymore since y has been replaced by 2, equals k over square root of 1 plus 8, which is the square root of 9, which in turn is 3. So we have 2 equals k over 3. If we multiply both sides by 3, we get 6 equals k. So now we have a value for k, which means we can put this into the same equation, but for our new value, when x equals 15. So we have y, as y is our unknown, equals 6, which is our original k value, over square root of 1 plus 15. This is the square root of 16, which equals 4. So y equals 6 over 4. Or, in turn, 3 over 2. So you can give your answer in various forms. You can either give it as 3 over 2, or 1.5, or 1.5. What matters is that it's 3 over 2 in some shape or form. So, when x equals 15, y equals 3 over 2, 1.5, or 1.5. All are equal to the same value. Finally, question 22. Factorize completely a and b. So, let's start with a. A is 9t squared minus u squared. So to factorize, we first find a way to turn the 9 into something different. So we can have 3 squared, as 9 happens to be 3 squared, t squared minus u squared. Nothing much has changed yet. However, now we can turn it into a factorized equation. So we can now create brackets, because 3t times 3t equals 3 squared t squared, or 9t squared. And u, or minus u, times plus u equals negative u, squared. And there you go. We have our answer of 3t minus u times 3t plus u. It's a bit messily drawn, but you get the idea. Next up, 22b. 2c minus 4d minus pc plus 2pd. So to factorize this, we have to find common factors we can remove from different stages of the equation in order to continue factorizing. So here, an instant common factor is 2. So we can have 2c minus 2d minus pc plus 2pd. I'd recommend leaving this side untouched for now, as we're going to change that next. So this here contains p as a common factor. So we're going to remove p and put that outside the bracket, which means we'll get c, positive c. And in order to get plus 2pd, it would have to be negative p times negative 2d. As a negative times a negative equals a positive. So since we've got c2d repeating twice, we can now further simplify the equation to 2 minus p times c minus 2d. And that is our final answer. As this, if expanded, should give us this equation here. And that's it for today. I hope you enjoyed this video and found it helpful to preparing for your IGCSE. Tune in next time for a continuation of this paper, and thanks for watching.